Welcome to this online revision session for AQA FP2. This session will be doing the June 2011 question 4 on the topic of roots of polynomials. You can see with this question rather a large number of parts, but key things to be looking at here are the fact that we're dealing with a cubic equation, z cubed minus 2z squared plus k equals 0. Notice that the coefficient of z is 0, which will be important when we're considering the roots. And obviously the key facts for us to remember are to do with the fact that alpha plus beta plus gamma, the sum of the roots is minus b over a. The pairwise product, alpha beta plus beta gamma plus gamma alpha, summed is c over a. And the product of the roots alpha beta gamma is minus d over a. Well, looking at the first part of this question, we can see part 1 fairly straightforward in that we know the sum of the roots is going to be minus b over a. So we'll just jot down at the top here, minus b over a, therefore must be, well, b is negative 2 and a is 1. So we know this is just going to be an answer of 2. And similarly, the pairwise product we know is equal to c over a, and as we said, c is the coefficients of z, which in this case is 0. Fairly straightforward. Part 2 of this question is we've got to show that the sum of the alpha squareds, in the shorthand notation, is equal to 4. And there is a useful identity which we either work out or we just happen to know, or we learn it, is the fact the sum of the alpha squareds is the same as the sum of the alphas all squared. That's alpha plus beta plus gamma all squared. But we know that that generates alpha betas and beta gammas and gamma alphas that we don't want, and in fact it generates 2 lots of them. So it's minus twice alpha beta plus beta gamma plus gamma alpha. And since we know the value of the sum of the alphas is 2, we know this value therefore is going to be 2 squared minus, well, on this other part we know is twice 0, because that was also a value we worked out in part 1 of the question. And so we get the answer of 4 as required. Part 3 then says explain. Well, I'll let you write this down. I'm not going to write it down, I'm just going to talk about it. The fact that, well, what do we know about alpha? Alpha is a root of this original equation. What do we mean by an equation? Well, by a root. Well, that means that is the solution to the equation, or one of the solutions to the equation. So we know that alpha will fit that equation. And so that's what you need to explain to get your 1 mark in part 3. Part 4 then goes on to, we've got to show that the alpha cubes plus the beta cubes plus the gamma cubes equals 8 minus 3k. Well, in part 3 we've just said that alpha cubed minus 2 alpha squared plus k equals 0. That's true for alpha. Well, alpha is just one of the roots. So similarly, we have a statement that's true for beta cubed minus 2 beta squared plus k equals 0, and similarly gamma cubed minus 2 gamma squared plus k must equal 0. So if we add those 3 things together, what do we get? Well, we got, that's the statement for alpha, and similarly we got the similar statement for beta cubed minus 2 beta squared plus k, and similarly we have a statement for gamma cubed minus 2 gamma squared plus k, and we know each of those things is equal to 0, so the sum of them will be 0. So if we collect the terms together, what have we got? Well, we've got alpha cubed and a beta cubed and a gamma cubed as required from each part. And if we take the remaining terms across to the other side, we can see we've got 2 alpha squared and a 2 beta squared and a 2 gamma squared all heading across to the other side. So if we factorise that at the same time, we get twice alpha squared plus beta squared plus gamma squared, and we got a k and a k and a k, so when they moved across we get minus 3k. Then we can finish it off, because what do we know about alpha squared plus beta squared plus gamma squared? Well, what did we say? That was equal to 4. So this becomes 2 times 4 minus 3k, which gives us our 8 minus 3k as required. Okay, so where do we get the marks from in all of this? Well, we know we're going to get a statement mark for this one and a mark for stating the value of this one. In part 2, we're going to get a method mark here for knowing how to rewrite the sum of the alpha squareds, and an accuracy mark for coming up with a correct value at the end of it. And then part 3, that was an explanation mark, so it's just 1 mark for understanding why alpha fits that particular expression. And then in this part again, it's going to be a case of recognising a method mark for coming up with the sum of the alphas cubed, and then an accuracy mark again, getting the correct statement at the end. Okay, well, move on to part B. You can see we're given that alpha to the 4th and beta to the 4th and gamma to the 4th equals 0. So that would seem to be our starting point for this particular part in order to find k. Now, the question is, what do we know about alpha to the 4th? Well, the answer is I know nothing about alpha to the 4th at the moment, but I do know from the previous part that alpha cubed is equal to, alpha cubed, let's just go back a page, alpha cubed minus 2 alpha squared plus k is equal to 0. So if we multiply through by alpha, we get the fact that alpha to the 4th will be equal to, minus 2 alpha cubed plus k alpha must also equal 0. Now, not only is that statement true for alpha, we know it's true for beta to the 4th and similarly the gamma to the 4th statement. So once again we can add those statements together and we will get the fact that the sum of the alpha to the 4th, in other words alpha to the 4th plus beta to the 4th plus gamma to the 4th, minus twice the sum of the alpha cubes, that's alpha cubed plus beta cubed plus gamma cubed, plus k lots of the sum of the alphas must equal 0. Okay, so all I've done there is taken the 2 and the k out as factors in front of the summation. So the sum of the alpha to the 4ths minus twice. Well, what do we know about the sum of the alpha cubes? Well, in the previous part we found out this was equal to 8 minus 3k, and then we got k lots of the sum of the alphas, and the sum of the alphas we know is 2, and that must equal 0. Now, in fact, the sum of the alpha to the fourth we also know because that was given at the beginning of part B. This is 0 as well, so this goes out. So what have we now got? Well, if we multiply out the brackets, we got minus 16, and then we get plus 6k plus the 2k, so that's plus 8k equals 0. So if we then take the 16 across, divide by 8, it gives us k equals 2. Okay, as required. A little bit tricky, that part. Then it says find. Well, what is it asking us to find? Well, it's asking us to find the sum of the alphas to the power of 5. Well, what do we know about alpha to the power of 5? Right, well, if we do that over here, if we again use the same reasoning as we did previously, we can write down, taking this statement for alpha to the 4, that alpha to the power of 5 minus twice alpha to the power of 4 plus k lots of alpha squared equals 0. And we can repeat that for beta and gamma. So when we then add those together, we get the sum of the alpha to the 5s minus twice the sum of the alphas to the power of 4 plus k lots of the sum of the alpha squareds equals 0. Well, what do I know about alpha to the power of 4? Well, at the beginning of this question we were told that value was 0. And then what do I know about the sum of the alpha squareds? Well, I know that k is 2 and the sum of the alpha squareds is 4. And so rearranging that tells me that the sum of the alpha squareds is equal to -8. Done. Well, where are we going to get the marks in each part of this question? Well, starting with this, finding this statement for alpha to the 4th minus the 2 alpha cubed plus k alpha equals 0, you will get a mark for that statement. Then there's going to be a method mark for coming up with the summation of all of those roots, and an accuracy mark for getting this statement here, and finally an accuracy mark for coming up with k as being a value of 2. And then in part 2, similarly, you'll get a method mark for coming up with the correct statement here. You'll then get an accuracy mark for substituting in the values for the sum of the alpha to the 4th and the sum of the alpha squareds, and then finally an accuracy mark for getting the correct answer. Sorry, that should be the sum of the alphas to the 5. My apologies for that misprint there. Okay. Well, I hope you found that solution useful. For more help, please go to the Further Maths Support Programme website.